Hi there, Mr. Arnold here for Hegarty Maths, and this is a video tutorial on simultaneous equations aimed at core maths modules. Okay, so you would have come across simultaneous equations in your studies before, but at A level in particular they're a little bit more involved. And it is important to note that simultaneous equations are normally used or often used, should I say, to find an intersection between two lines or two curves or maybe a line in a circle. So it's a really powerful technique that's often used to find a point or points of intersection. Now there's two techniques that we're going to study today, the first of which is solving by elimination. So we've got two equations here with two unknowns, and the only way we can solve an equation with two unknowns is if we have at least two equations. So one of the first things that I like to do is I like to label my equations just so that I know what I'm doing with them. So I'm going to call the top equation here equation A, and I'm going to call the bottom equation equation B. Now, in order to eliminate, what we need is we need the coefficient, that's the number in front of a variable, so the coefficient of the x's need to be the same, or the coefficient of the y's need to be the same. So I'm looking at these two equations here, A and B, and I'm thinking, well, if I double equation A, the coefficient of x will be the same for both. So I'm going to just draw a little line underneath, and what we're going to do is we're going to double equation A. So doubling equation A, we get, now remember we must double everything, 4x, let's make a little bit more space, 4x minus 2y equals 12. So you must do the exact same thing to both sides. Equation B I'm going to leave alone, so equation A is there. Equation B I don't need to touch, I'm going to leave it as it is. So that's still 4x plus 3y equals 22. And now we can eliminate one of the variables. So I'm going to draw the line underneath again. And what I'm going to do now is I'm going to do equation B take away equation A. So I'm doing equation B take away equation A. So 4x take away 4x is 0, so they cancel out, which is exactly what we wanted to happen. One of them is eliminated. And then I do 3y take away negative 2y, which is the same as 3y plus 2y. So that gives us 5y. And then 22 take away 12 is 10. So 5y is equal to 10. That means that y must be equal to 2. So now I know what y is. I can substitute back into any equation I like and work out what x will be. So I'm going to substitute y equal to 2 into, now let me decide which equation I want to go for. I'm going to choose equation A up here. This one here is the one to go for, in my opinion, because it's we just have y. I don't need to multiply anything. So into equation A. So we get 2x subtract y, or in this case subtract 2, must be equal to 6. And then we should be able to solve for A. So let's add 2 to both sides. We get 2x equals 8. And then finally, x will equal 2. So I know x equals 4 and y equals 2. And believe it or not, that's a coordinate. That's the coordinate 4, 2. And I'm just going to bring up Desmos here to show you that we found the point of intersection between two lines, and that point will be 4, 2. So if you go to Desmos, the first equation was 2x minus y equals 6. So put that in. And the second equation was 4x plus 3y equals 22. 4x plus 3y equals 22. And if we have a look here, we see the point of intersection between the two lines is 4, 2, and the solution, lo and behold, was 4, 2. So it's a really powerful technique. Okay, let's do another example. So we got 3x plus 8y equals 33, and 6x equals 3 plus 5y. Now the first problem I have here is it looks slightly different to what we've had before. So I'm going to manipulate equation B. Let's just label them again. That's equation A. That's equation B. I'm going to manipulate equation B so that it looks, so I have x and y on one side and then any constant on the other side. Okay, let's leave equation A alone. Let's draw a line underneath here. Leaving equation A alone, that's still 3x plus 8y equals 33. That's equation A. And equation B, I'm going to subtract 5y from both sides. So we get 6x minus 5y equals 3. Okay, and in order to eliminate, we need to have the same coefficient. Do bear in mind, sometimes you need to multiply a by something and multiply b by something, but in this question, I'm only going to have to multiply a by 2 in this case. So I'm going to multiply equation A by 2. Let's draw a line underneath here. So equation A now becomes, remember to double everything, 6x plus 16y equals 66. Leave equation B alone. Equation B is fine. 6x minus 5y equals 3. Now what we can do is we can eliminate the x's because we have the same coefficient here. So we have the same number in front of the x's or the same number in front of the y's. We can do an elimination. The way I'm going to do that is I'm going to do equation A subtract equation B. So 6x take away 6x is 0, so they cancel out. 16y take away negative 5y is the same as 16y plus 5y, which will give me 21y. And then 66 take away 3 is 63. So 21y is 63. That means that y, dividing both sides by 21, is going to be equal to 3. So now I know what y is. I'm going to substitute that back into one of the equations. So sub y equal to 3 into, now which equation shall we go for? As I said before, you can choose any one you like. I'm just going to choose B, no particular reason. I'm going to choose this one here. I'm going to go back into this one. So replacing the y with 3. So we get 6x equals 3 plus, so 3 plus 5 times y plus 5 times y, which is 3. So let's tidy this up. We get 6x equals 3 plus, and 5 times 3 is 18, is 15 I mean. Jumping the gun there a little bit. 6x is going to be equal to 18. And then dividing both sides by 6, we get x equals 18 divided by 6 is 3. Now I'm not going to go back to Desmos for this. You can, if you like, look, try it out yourself, see if it works. The solution is going to be 3 and 3. So these two lines cross at the point 3, 3. So that's how we do elimination. Okay, now another method we have is substitution. Okay, and a key indicator to use this method is if you have a linear equation and a higher order equation. So if you look here, we have a linear equation that's in the form y equals mx plus c, straight line. The highest power is 1. But this one here is not a linear equation. We can see that this is actually a quadratic, so it's some sort of curve like that. and this is a line, something like that. So I would expect to have two solutions. I expect the line to cross it twice. So we need to use the method of substitution here. So I know that y equals 4x plus 11. So let's actually label them again. That's equation A and that's equation B. And I'm going to sub y equal to 4x plus 11 into B. Let me just draw a line underneath this here. So I'm subbing y equal to 4x plus 11 into B. So wherever I have a y, I'm going to put 4x plus 11. So we get 4x plus 11 will be equal to x squared plus 3x minus 1. I'm going to bring everything to one side and set it equal to 0. It's going to be equal to 0, so I'll still have x squared. I'm going to take 4x off both sides. So 3x take away 4x is negative x. And then I'm going to take 11 off both sides. So we get negative 1, take away 11 is negative 12. Okay, so I've got a quadratic here. X squared minus x minus 12 is equal to 0. We should be able to factorize this. I'm thinking x and x. And that will be equal to 0. So two numbers that multiply to give negative 11, but add to give negative 1. Minus 4 plus 3. So that means if this times this is 0, that means x minus 4 must be equal to 0. Or x plus 3 will be equal to 0. So that means that x equals 4. Or x equals negative 3. Now I'm going to have to substitute both values back in to get their corresponding y. So when x equals 4, now you might ask yourself, which one will I go into? It doesn't matter which one you choose, but hopefully you realize that subbing it into equation A is much easier. So let's just write it down again. Y was equal to 4x plus 11. Y equals 4x plus 11, that's alright. So that means I'm going to substitute the 4 in first. Let's substitute the 4 in. We get y equals 4 times 4 plus 11. That means y equals 16 plus 11, which means y equals 27. Let's just move this over here. So when x is 4, y is 27. And what about when x is negative 3? Well, that means y will equal 4 times negative 3 plus 11. So y equals 4 times negative 3 is negative 12. And we've got to add 11 to that, which means y equals negative 1. So the solutions I have, when x equals 4, y will be 27. And when x equals negative 3, y will equal negative 1. Let's go back to Desmos and just see how we did. So y equals 4x plus 11. Clear that, clear that. Y equals 4x plus 11. And can't stress, guys, the power of this application, Desmos. It's brilliant and really good to work with any sort of graphs. X squared plus 3x plus 1. So y equals x squared plus 3x plus 1. And I'm hoping that, have I done that right? X squared plus 3x minus 1. Minus 1. I thought that was a funny looking answer. Minus 1. So one of the solutions is here. Negative 3, negative 1. Did we have that? Absolutely. Negative 3, negative 1. And I'm hoping, oh, let's scroll back out a wee bit. Up we go. all the way up here, we can see that the line and the quadratic cross here at 4 and 27, and lo and behold, that's exactly what we got. Okay, let's move on. So x squared minus y plus 3 equals 0, and x minus y plus 5 equals 0. Take your pick about which way you'd like to do this. What I'm going to do is I'm going to add y to both sides for equation b. So remember, this is a linear equation here. That's some sort of higher order equation, so I need to sub the linear equation into the higher order equation. So a and b. So what we're going to do is we're going to sub b into a. Now before I sub b into a, I'm just going to manipulate it a little bit. So I'm going to isolate the y. Let's add y to both sides. So we get x plus 5 equals y. In other words, that y equals x plus 5. So let's have a look at what happens with equation a. In fact, let's write that down again. That's equation b. We've changed that. And now what we're going to do is we're going to sub y equal to x plus 5, which is equation b, into a. Okie doke. Right, we get, so equation a now becomes x squared minus, so I'm subtracting whatever y is, and y is x plus 5. It's important to put the brackets up here, just in case that's negative. If I'm taking away a negative number, that's the same as adding it, so I just need to be aware of that. Put brackets around it, protect the x plus 5. Plus 3 equals 0. So that means x squared minus x, and then minus positive 5 is the same as subtract 5 or minus 5, plus 3 equals 0. So x squared minus x, and minus 5 plus 3 is minus 2, and that will be equal to 0. So here we are again. We've got a quadratic, should be able to factorize it. I'm thinking x and x, it's going to be equal to 0 in the end. Right, two numbers that multiply to make minus 2, but add to make minus 1. So x minus 2 and x plus 1. So that means that x minus 2 is equal to 0. Or some people might say and. It's really much of a muchness, it's not a huge big deal. X plus 1 is equal to 0. So x must be equal to 2. Or x must be equal to negative 1. Now we're going to substitute the values of x back in. I'm going to go back into equation b. Okay, equation b is a lot easier because I don't need to square anything. So x minus y plus 5. In fact, let me use this manipulated version. X plus 5 equals y. So we got x plus 5 equals y. So I'm subbing into this equation now. So we get 2 plus 5 will be equal to y. And then over here, we're going to get negative 1 plus 5 will be equal to y. So, in other words, y is going to be equal to 7, and y will be equal to 4. So the solutions are when x is 2, y is 7. When x is negative 1, y is 4. If you don't believe me, check it on Desmos. Okay. Second last example, okay? So again, we've got a linear equation here, and I've got a higher order equation here. Right, this one is going to be a little bit tricky, but we're still going to be able to have a stab at it. Okay. So, let's draw a line underneath this one here. Okay, equation A and equation B. Now, I have a feeling this is going to get complicated, but we'll do our best. Right, I'm going to manipulate equation B. So I know that 3x will equal, in fact I'm not going to do 3x, I'm going to isolate the y, isolate y here. So 2y will equal 6 minus 3x, which means that y will equal, divide everything by 2, so 6 divided by 2 is 3, minus, and then it's easier to leave this as a fraction, 3 over 2 times x, so it's 3 over 2x, so that's what y is, and this is equation B. I could have gone and isolated x, still would have worked, but it's easier, in my opinion, to go for the y, because then I don't have to worry about squaring anything. Okay, so let's sub y equal to 3 minus 3 over 2x into equation A. So equation A, we get x squared plus x times, now where I have a y I'm going to put in 3 minus 3 over 2 lots of x, and that must be equal to 4. So let's keep going here, x squared, expand in the bracket, plus 3x, and then x times negative 3 over 2x is negative 3 over 2x squared, and that's equal to 4. Okay, so let's collect our like terms together. X squared minus 3 over 2x is minus a half x squared plus 3x. I'm going to take 4 off both sides as well here so that it's equal to 0. Take away 4 will be equal to 0. Now at this moment in time, it's still quite tricky. Let's just make that a bit clearer. That's a 2. Okay, but because it's equal to 0 now, I can do a few things with it to make life a little bit easier. I'm going to multiply everything by 2 to get rid of this fraction. So I get minus, let's just write that down. We're multiplying everything by 2 to get rid of the fraction. So we get minus x squared plus 6x, take away 8 is going to be equal to 0. So multiplying everything by 2. And I don't like this negative sign here in front of the x squared because I'm not used to factorizing like that. So I'm going to multiply everything by minus 1. Now really what I could have done was multiplied everything by negative 2, and that would have done, it would have killed the 2 birds with 1 stone, but we just want to make things nice and clear. So multiplying everything by minus 1, in other words, change the sign of everything, is equal to 0. Okay, now we can factorize this. So we want x and x. What am I doing? Not in there. X and open the bracket here. X equal to 0. Two numbers that multiply to make 8 but add to make negative 6. Now I'm thinking 4 and 2. Negative 4 and negative 2. If I multiply those together, I get positive 8. If I add them together, I get negative 6. So that's spot on. That means x minus 4 is equal to 0, or x minus 2 is going to be equal to 0, which means that x equals 4 or x equals 2. And then we're going to substitute these guys back into one of the equations. So let's go all the way back up here. Which one is the best to use? I'm not too happy with this one because we have a fraction. So let's go with this one here. 3x plus 2y equals 6. So it was 3x plus 2y equals 6. Right. Substituting back in, we're going to get 3 times 4 plus 2y will be equal to 6. 3 times 4 is 12 plus 2y is equal to 6. Take 12 off both sides, so we get 2y equals 6 take away 12 is negative 6, which means that y will be equal to negative 3. That's the first one though. So let's go back here. Now I've got to substitute in 2, so we get 3 times 2 plus 2y will be equal to 6. And now expanding this out, we get 6 plus 2y will be equal to 6, which means 2y is equal to 0, which means y is equal to 0. Now I am going to prove that this one worked. Let's just write down the solutions again. Here we had 4 and negative 3, and over here we have 2 and 0. 4, negative 3 and 2, 0. So let's go all the way back up here over to Desmos just to confirm what I'm fairly certain is right. We had x squared plus xy equals 4 and the other one 3x plus 2y equals 6. 3x plus 2y equals 6. Right, how did we do? Right, I can see one solution here, 2, 0. Did we have that? Absolutely right. And then the other one we have 4 minus 3. Absolutely right. You can see it's a fun, this graph here, the orange graph, is quite a complicated graph. But there's our two solutions. That's where the line cuts it. Okay, we got one more to go. So the last type of question that we might have to do, something like this, same idea again, although it doesn't look like we have a higher order equation, but in fact we do. So if we look at this one here, call it equation A, and this one is equation B. Now the thing I don't like about equation A is that I have an x underneath the line. That's really, really irritating. So let's sort that out. So if I take equation A and I multiply everything by x, to eliminate that. If I multiply this term by x, I just get 3. Because I'd have x on top over x on the bottom, and the two x's cancel out, so that leaves me with just a 3. Minus 2xy, so multiplying everything by x, plus 4x will be equal to 0. Equation B, leave it alone. 4x plus y, take away 7, equals 0. And this one is actually going to work out quite nicely, because you might notice I'm going to isolate 4x here. So take equation B. Right, I'm still going to work with equation B here. Equation B, 4x will equal 7 minus y. So adding 7 to the other side, adding 7 to both sides, should I say, and then subtracting y from both sides. So 4x is 7 minus y. And you might notice in equation A, here he is here, I have 4x. So in equation, oh, that's not actually going to help. Let's isolate x. Isolate x. Let's go. In fact, let's isolate y. So sorry for the confusion. Now let's isolate y. Get rid of all of this. I thought I found a shortcut. I didn't, but thankfully I spotted that I hadn't made the mistake. Y is going to equal 7 minus 4x. Okay, so y is 7 minus 4x. So now I'm going to sub equation B, or sub y equal to 7 minus 4x into A. So what do we get? 3 minus 2 times x times, and where I have a y, I'm going to put in 7 minus 4x plus 4x, and that's equal to 0. And then I'm going to have to expand this out, so we get 3 minus 14x plus 8x squared. So negative 2x times negative 4x is positive 8x squared, plus the 4x that was hanging out here, that's equal to 0. And hopefully you notice I can see a quadratic here, tidying things up. X squared, 8x squared, right, gathering our terms, negative 14x plus 4x is negative 10x, and then we've got the 3 plus 3, and that's going to be equal to 0. Okay, now this is going to be a particularly tricky one to factorize. Lots of different methods you can use, but I'm going to do 8 times 3. So this times this, 8, 16, we get 24. So I'm going to think two numbers that multiply to make 24 but add to make negative 10. Let's have a think. 8, 4 doesn't work. 12 and 2. 12 and a 2. 12 and a 2 will work perfectly. This bit in green is not actually part of the question. It's kind of like rough work. So I'm going to write 8x in both brackets. So Mr. Hegarty's done a video on this just in case you haven't seen it. 8x in both brackets. I'm going to do 12 and 2. And then in order to make negative 10, that would have to be negative. That would have to be positive. Now the other thing I need to do is I've multiplied by 8. I did 8 times 3. So I need to divide by that 8 just to get things back in balance. I can divide this one by 4. So I can divide this one by 4, we get 2x minus 3, and I can divide this one by 2, which will give me 4x plus 1. Yeah, I multiplied by 8, I've divided this one by 4, and I've divided this one by 2. Dividing by 4 and dividing by 2, same as dividing by 8. So the universe is back in balance. Alright, 2x minus 3 equals 0. And 4x plus 1 is equal to 0. So that means that 2x equals 3, 4x equals negative 1, 2x will equal, sorry, not 2x, x will equal 3 over 2, and x will equal negative 1 over 4. Numbers here are getting more and more complicated by the second. I'm going to use this equation here, so I'm going to substitute x into this one here, y equals 7 minus 4x. So we had y equals 7 minus 4x. Okay, so substituting this one in, y equals 7 minus 4 times, and x is 3 over 2. And then over here, I'll come back to that one in a second. Y equals 7 minus 4 times 3 over 2 will give me minus 12 over 2, which is minus 6. So that means y equals 1. And then over here, y equals negative 4. So y equals 7 minus 4 times negative 1 over 4. So y will equal 7, and negative 4 times negative a quarter is plus 1, which means y equals 7 and 1 is 8. So let's just write down our solutions. When x is 3 over 2, y will be 1, and when x is negative 1 quarter, y will be 8. Okay, right, I'm not going to put that into Desmos because we're running on here a little bit. Hopefully you found that video useful. A lot of complicated things going on there, so if you didn't get it the first time, do rewatch the video, maybe pause it at some relevant points and try some of the questions yourself. But that's all for now. Hopefully you found it useful. I'll be back again with another video soon. All the best and good luck with your revision.